Hello guys, welcome back. Today we will be doing tangent vectors, unit tangent vectors, normal vectors and binormal vectors. So let's start with tangent and unit tangent vectors. So a tangent vector is defined as the derivative of the vector function. So suppose we have a vector function r of t, then its tangent vector is just the derivative of r of t, that's r prime of t. So here we are saying that r prime of t should not be equal to 0, because if it's 0 then we are going to have the 0 vector. So now then, to find the unit tangent vector, we just find the unit vector in the direction of the tangent vector. The unit tangent vector is defined as r prime divided by the magnitude of r prime. That's the tangent vector divided by the norm of the tangent vector, right? So here also we are saying that r prime of t should not be equal to 0, because if r prime of t is equal to 0 then its magnitude is also 0. So we are going to have 0 on 0, which is indeterminate. Now we know how to find the tangent vector and the unit tangent vector. Let's now solve some examples. So our first example, we are given the vector to be r of t, which is equal to t 3 sine of t 3 cosine of t, and we are being asked to find the tangent vector r prime of t. That's just, we just have to differentiate the vector function. And 2, we are to find the unit tangent vector t of t, and the last one is to find the vector equation of the tangent line to the curve given by r of t and t is equal to pi on 4. So to find the tangent vector, we just have to differentiate our vector function, right? So we are going to have r prime of t to be equal to, when we differentiate t with respect to t, we are going to have 1 out of the j component will give us 3 cosine of t, and the k component will give us minus 3 sine of t. So we have our tangent vector given below. So now let's move on to find the unit tangent vector. So by definition, the unit tangent vector capital T of t is defined to be the tangent vector divided by its magnitude. So now we first have to find the magnitude of the tangent vector. So now let's find the magnitude. So magnitude of r prime of t will be given as the square root 1 squared plus 3 cosine of t squared plus minus 3 sine of t squared. Now let's simplify. So we are going to have 1 plus 9 cosine squared of t plus 9 sine squared of t, all square roots. So here we can factorize 9 out from the last two terms. So we are going to have cosine squared of t plus sine squared of t, and cosine squared of t plus sine squared of t is equal to 1. So our answer is going to be the square root of 1 plus 9, and that's square root of 10. So we have the magnitude of the tangent vector as square root of 10. So now we move on to find the unit tangent vector. So we are going to have capital T of t is equal to, so we had our tangent vector to be 1 3 cosine of t minus 3 sine of t, then divided by the magnitude, which is now square root of 10. So we are going to have 1 root of 10 out, 1 3 cosine of t minus 3 sine of t. So this is our unit tangent vector. With the last question, we have to find the vector equation of the tangent line to the curve given by r of t and t is equal to pi on 2. So we know that the equation of a line is given by r of t is equal to r naught plus v of t, where v is the parallel vector and r naught is a point on the line. Right, so now here also we just need to find these 2 points and we can now solve our question. So now here we need to find a point on the curve given by r of t. So let's move on to find our point r naught at t is equal to pi on 4. Now we had our vector function given as r of t, so then r of pi over 4 will be given as pi on 4 3 sine of pi on 4 3 cosine of pi on 4, because we have to find it as point t is equal to pi on 4. So this will simplify to pi on 4 3 roots of 2 then 3 roots of 2. So here this is our point r naught. Now let's move on to find the parallel vector. We had our tangent vector to be given as 3 cosine of t minus 3 sine of t. We now compute a vector which is parallel to this tangent vector at t is equal to pi on 4. So we are going to have 3 cosine of pi on 4 minus 3 sine of pi over 4. So this is going to give us 3 square roots of 2 minus 3 square roots of 2. We have everything that we need to find the equation of the line. So we are going to have the equation of the line given as r of t is equal to r naught plus v of t. Now what was our r naught? That was the point on the curve, so that's going to give us pi on 4 3 roots of 2 3 roots of 2 plus, now what's our parallel vector? That's what we have as 3 roots of 2 minus 3 roots of 2 then multiplying t. This is our equation of the tangent line to the curve. So we now move on to normal and binormal vectors. By definition, the unit normal vector is defined as the derivative of the unit tangent vector divided by its norm. So that's t prime divided by the norm of t prime. Also, the binormal vector is defined as the cross product between the unit tangent vector and the unit normal vector. So we now move on to solve some examples on unit normal vector and binormal vectors. So here we are to compute the unit normal vector and the binormal vector given the vector function t 2 sine of t and 2 cosine of t. To compute the unit normal vector, we first have to compute the unit tangent vector. Let's first compute the unit tangent vector. So we are going to have r prime of t to be given as 2 cosine of t minus 2 sine of t. Then we find the norm of this guy. So that's going to give us the square root of 1 plus 4 cosine squared of t plus 4 sine squared of t. So we are going to have 1 plus 4 out cosine squared of t plus sine squared of t. So that's going to give us 1 plus 4. Our norm is square root of 5. Hence, our unit tangent vector is giving us 1 on root of 5, 1, 2 cosine of t minus 2 sine of t. So then we can now move on to find our normal vector. To find the unit normal vector, we have to differentiate the unit tangent vector, then we divide by its norm. So let's now compute t prime of t. So that's going to give us 1 root of 5. When we differentiate 1, we are going to have 0. Then we now differentiate 2 cosine of t, and that's going to give us minus 2 sine of t. And likewise, we are going to have minus 2 cosine of t. Then we find the norm of this guy. So the magnitude of t prime of t will be giving us the square root 1 on root of 5 all squared, then 0 squared plus 4 sine squared of t plus 4 cosine squared of t. So we are going to have 1 on 5, 4 into brackets sine squared of t plus cosine squared of t. So we are going to get 4 on 5 all squared. So that's going to give us 2 root of 5. So we are going to have our unit normal vector giving us 1 root of 5, 0 minus 2 sine of t minus 2 cosine of t divided by the magnitude of t prime, which is 2 root of 5. So this will simplify to 1 root of 5 multiplying root of 5 on 2, 0 minus 2 sine of t minus 2 cosine of t. So these two guys will cancel out. So we are going to have it to be 1/2 0 minus 2 sine of t minus 2 cosine of t. We are going to have our answer to be 0 minus sine of t minus cosine of t. So this is our unit normal vector. Now let's move on to find the binormal vector. Binormal vector is defined as the cross product between the unit tangent vector and the unit normal vector. So from above we have our unit tangent vector to be given as this guy and the unit normal vector given as this guy. So we just have to find the cross product between these two guys. So the binormal vector b of t is defined as the determinant of the 3x3 matrix, where the first row is the basis vectors I, j, and k. Here the second row will be given as the entries of the unit tangent vector. So that will give us 1 square root of 5, 2 cosine of t square root of 5, then minus 2 sine of t square root of 5. And the third row will be given by the entries of the unit normal vector. That's 0 minus sine of t minus cosine of t. So now let's now compute this guy. Here we cancel the first row and the first column. So we're going to have I, then minus 2 cosine squared of t on square root of 5 minus 2 sine squared of t divided by square root of 5 minus j. So we cancel the second column and the first row. So that's going to give us minus cosine of t square root of 5 minus 0. So we now cancel the third row and the first column. So that's going to give us minus sine of t square root of 5. So with the first term, we can factorize minus 2 square root of 5 out. So you're going to have minus 2 square root of 5i, then cosine squared of t plus sine squared of t, then plus j cosine of t square root of 5 minus k sine of t square root of 5. So now this guy will now go to 1. So we are going to have minus 2 square root of 5i plus cosine of t square root of 5j minus sine t square root of 5k. So, see you in the next video. Bye.